Good evening, madam. My name is Harsha Kaur from BMI Kaur 10, and today I'm going to be talking about digital computed radiography. Okay, so digital imaging is defined as the formation of a digital image of an anatomical structure which goes through a certain process to obtain the electronic image, whereby the image can be controlled and seen on a computer. So digital radiography system is divided into two, which is computed radiography CR and direct digital radiography DDR. Okay, so for CR is also called as indirect digital radiography because it uses a cassette containing a PSP plate. So once the imaging plate is exposed to radiation, the PSP imaging plate layer will absorb the X-ray energy and store the electrons in latent image in a higher energy state due to the ionization of crystal electrons, which produces electron hole pair. And then the CR cassette is placed into a CR scanner, which will go through a process called photostimulated luminescence process, whereby the red laser beam will read the latent image of the imaging plate in raster pattern and release the trapped electrons, allowing them to return to their original state. So once they return to the original state, visible light is produced, which will be collected by the optical systems and directed to the photomultiplier tube. So the photomultiplier tube converts the visible light to electronic signal, and then the ADC, analog digital converter, will convert the electronic signal to digital image to be processed by the monitor. So if there are no errors on the image will be downloaded into a computer, where it can be manipulated and transferred to a picture archiving and communication system, PACS. Okay, so for direct digital radiography DDR, it does not use a cassette. It converts X-ray energy directly to digital signal, which can be seen on the monitor. So DDR is divided into direct acquisition, which requires photoconductor and TFT, and indirect acquisition, which involves a scintillator, photodiode, TFT, and CCD. Okay, so as for indirect conversion of flat panel detector, once the calcium iodide phosphoscintillator is exposed, the X-ray photons will provide energy to the electron to excite to a higher orbit, but the electrons will drop instantly to its original orbit, releasing light photons due to no electron traps in the phosphor. So the amorphous silicon TFT array contains pixels, and each pixel contains charge storage capacitor, TFT switch, and the sensing area, which will carry out their respective functions to convert light photons into electrical charge, to store the electrical charge, and to read the latent image produced. Okay, so the electrical signal will then be sent to the AC to be converted into digital signal. So as for indirect conversion of charge coupled device detector, the scintillator must couple with the CCD by lenses or fiber optics. So a screen is used as a scintillator, and the light produced from the interaction of the scintillator and the X-ray photons will be converted immediately into electric charge by CCD, which will be sent to the computer for image processing. Okay, as for direct conversion, scintillator is not required, but it requires a photoconductor and TFT. So the photoconductor used is amorphous selenium, which will absorb the X-ray photon and convert it into electrical charge carriers with negative electrons and positive holes. So the electrons that are attracted to the electrode, which is positively charged, will be disposed, while the positive charges that are attracted to the charge storage capacitor in the TFT array will form the latent image. So the TFT switches in each pixel will be activated to read the latent image produced. So the switch will then produce a voltage signal, which is computerized and moved to the computer for the DDR image to be formed. Okay, so as for image display, even though digital images can still be displayed on film, which means in hard copy, but soft copy display is still recommended because it can view the same image multiple times in multiple locations. Number of lost films can be reduced, and the density, brightness, sensitivity and contrast can be manipulated. So there are two types of image display, which is hard copy and soft copy. So for hard copy display, the images are visualized on a film, which will then be read line by line in raster pattern by the laser printer, which will then be processed by either wet or dry processing method. And as for soft copy display, the images are visualized on monitor by the flat panel technology of or cathode ray tube. That will be all from me. Thank you.